Okay, hello everyone, and welcome to the VMware NSX and vCloud Automation Center Integration Technical Deep Dive. So my name is Ray Budavari. I am a member of the NSX product management team in the Network and Security Business Unit at VMware. So I kind of have the good fortune of getting to work on all things related to NSX.
And my name is Zach Keelik. I'm one of the technical marketing managers focusing on VCAC and VCO. That runs the gamut between plugins as well as VCAC, technical deep dives as well. And yeah, so today we'll have a pretty exciting conversation for you here.
Okay, so before we jump into the content, Zach and I wanted to get an understanding, of our audience today. So who here has been to an NSX session either at VMworld or another event?
Wow,
fantastic.
Yeah. Awesome.
Okay, maybe some of you guys should be doing the technical deep dive then. And who has hands-on experience with NSX, either through the hands-on labs, maybe a POC, or a deployment? Okay, excellent. And now maybe the same question for vCloud Automation Center, who has hands-on experience with the product?
All right.
Okay, good audience today. And finally, vCenter Orchestrator.
Now,
okay.
How many of you are actually using it in your environments? Keep those hands up. Ah, more and more every single year. That's awesome.
Okay, so we are covering the integration in our upcoming 6.1 release. So the standard disclaimers apply. We're talking about product that hasn't shipped yet, et cetera, et cetera. So our agenda, we're going to provide a background on kind of the problem that we're trying to address with the integration of NSX and VCAC. Then talk about how this integration works, what's new and coming in the 6.1 releases. Then talk about the deployment topologies, which is something I think is very important. Not only how the technology works, but how does this map to actual application architectures. Then the always risky live demonstration, followed by Q&A.
Great. So, thanks, Ray. Let's go from here. Thanks. So just to, it's after lunch, figured we'd ease you all back into this. So many of you already live and breathe this on a day-to-day basis, but this is basically what NSX is looking to do, as well as, VCAC, that integration. So we're looking to, as users and those super users, we're looking to get that environment deployed to us as fast as possible, right? Super users want it a specific way. They want the way that they want it. And then the regular users just want it, just give it to me as fast as possible so I can do my work. And then, of course, we've got our cloud admin over here looking like the most interesting man in the world with the beard going on. He says that, of course, we want to give it to you as fast as possible, but, I got to take into account SLAs and all this different stuff. So, and on top of that, I don't take care of the infrastructure, so I'm kind of, stuck in the middle here. On the counterpart of that, we have all of our corresponding admins, network admins, security admins, and load balancer admins. They're all concerned about, what happens if I give self-service to the end users? Does that mean that I lose control? All these different concerns start to come up. And then the load balance admins, they're talking about, well, is it because of me that we're, having slower product release cycles? Are you waiting for me to get stuff done? So all these people, have conflicting and sometimes contrasting ideas of the world and how things should be implemented. Let's see here. And then this is the typical process that we have today. You guys, probably see this all over VMware slides and probably experience this as well day to day. Is that you make a request, and you wait, and you wait, and you wait. And then, maybe there's a few minutes of touch time. But in order to free up those resources, the people to actually do the work, it takes a while, right? You're waiting for people to help out. So, just the work aspect of it is just that little tiny piece of it, but we have to wait a long time. And that a lot of times comes up with things like tickets. We have to go to the specific switch people, the router, the firewall. All these people require their own tickets in order to do the work. As soon as it's done, they click forward, and then it goes on to the next process. We need to automate all this, right? We need to get it so that we're not waiting for all that. Right?
Thank you, Zach.
Thanks.
So first question is why NSX? And sort of based on the answers, probably don't have to spend a lot of time here. But really, if I could summarize, NSX provides virtualized network and security services such as logical switching, routing, firewalling, and load balancing, in addition to constructs like security groups and security policies that really allow that policy to be applied in an automatable manner, decoupled from your underlying infrastructure, and really ready for consumption via cloud management system. So, if we take a look at a typical application, here we have, web, app, and database virtual machines. NSX logical switching provides us layer 2 connectivity, so our applications can communicate with each other. Then NSX also provides logical routing, so the different components, web can communicate with app and so forth. And it also provides connectivity to the required external networks. Then we have logical firewalling. So this is where we enforce security policy between those virtual machine tiers. Load balancing, so we can improve application availability by balancing our connections across multiple virtual machines. And then we have these security groups and policies. And so what you can see here is a default security group with a policy here that allows certain, access to certain shared service and antivirus. And in fact, the entire application itself is a member of that particular security group. Then we also have context of the application itself. So we can place web virtual machines into a security group and apply specific security policy for those web servers, allowing HTTP and HTTPS traffic and intrusion protection. Same thing with application and database. So you can see we maintain all of the context of that application. Sorry. So this is really what NSX gives you. Everything that you can see here is automatable and exposed through northbound APIs. So this is why it's such a complementary technology with vCloud Automation Center. So when we take all of these logical network and security services that NSX provides, switching, routing, firewalling, and load balancing, and we combine them with the core features of vCloud Automation Center. So this is the self-service portal, resource reservation, and blueprints. This is really how we're able to meet that goal of on-demand application delivery. And not only that, it's done in a templated and automatable manner so that we can keep deploying our applications as required. And really, this is the reason why so many NSX deployments will be interested in vCloud Automation Center, because it's with this automation that the capabilities of NSX really shine. So now I want to talk a little bit about application topologies, because it's really important in terms of how we build and consume the product. So vCloud Automation Center supports multiple application topologies. So on the left here, we kind of have the traditional multi-tier topology, where each tier has their own dedicated network, and it provides isolation and the ability to enforce control at layer 3. So it's very much the traditional application model you might be using today. And we also have on the right a more emerging model where we have a flat network, we have multiple security groups to keep that application context, but they're all sharing a common logical network. And the reason we can do this is that firewall enforcement with the NSX distributed firewall at the VNIC level. Now, even with the second option over here, where we have one application on a single flat network, there's also a variation of that, where we actually deploy multiple application instances on the same network. So, this is a model that's gaining popularity because, it reduces the number of moving parts that need to be automated, and it also simplifies IP address management. So, over in the traditional model, the cloud admin or application owner needs to decide. They need to make decisions on how large my subnets will be, and how large could the application potentially scale to, and then you need to go and provision all these components on demand. Whereas with a flat network, you can build a large address space and keep deploying your applications into that single logical network and keep consuming until you run out of IP addresses, and then you provision another flat network. And NSX even enables this model of building out large flat networks because we can leverage features in VXLAN like ARP suppression, where we're going to convert ARP requests into NSX control queries, and we're actually able to respond based on the network state in the NSX controller, rather than having to flood that ARP traffic across the entire segment. So not only do we allow you to build these constructs, but we also optimize as well. That being said, vCloud Automation Center supports both models, so there's neither right or wrong. They're just different topologies that you can deploy your applications with. Now, going back to Zach's point, we also understand that not all of the users are the same, and vCloud Automation Center supports different user types. So we might have the typical user who, to be honest, they just want their application and they want it fast. They don't care about the network and security. They want it taken care of for them. And by providing these blueprints or our application templates that include all the network and security configuration, that's exactly how we're able to meet those users' demands. They come in, consume those existing templates, and they no longer have to wait for network and security and handoff between multiple teams before they can get their application. We also have the power user, though, and this is the user who knows everything about their application. They know how it should be connected and how it should be secured. And in their case, they still want on-demand applications, though. They still don't want to wait and get bogged down with ticket requests and so forth. So in that case, they're able to take those blueprints or building blocks, apply the required customization on the blueprint, and still get their on-demand applications. So it's another key point that this integration is flexible and supports different types of user profiles. Now, there's a final area of background before we move on to the new and exciting features in our 6.1 release. I want to provide an overview of network profiles. And really, this is because all network connectivity in vCloud Automation Center is defined through network profiles. So understanding these options is really important in leveraging the integration with NSX. So first, we have 4 types of network profiles. So we have external networks that really map to pre-existing networks that are already configured in the environment. And we have these 3 dynamic networks: routed, NAT, and private. And so these networks are all created on demand. So they're configured dynamically by vCloud Automation Center based on the way the blueprint is configured as per your application requirements. So 1 is existing, 3 are dynamic. Another important point is that you need multi-machine blueprints to consume the NSX integration in vCloud Automation Center. And any networks that VCAC creates on demand, it will always use VXLAN logical switches. Probably my final point here is that these networks are not mutually exclusive either. So we can combine, for example, routed and private or NAT and private networks in the same blueprint. So this might be a case where we want our web tier to be accessible remotely, but our app and database tiers only need to be accessible to the web tier. So the integration is flexible in that regard. Now, in terms of where you would use these individual profiles, well, really, external network profiles, as I said, it's when you're connecting to a pre-created network. So if you think about it, this actually maps very closely to that single-tier flat network model, the flat network topology that we showed in previous slides. So external networks are not necessarily bad. It's just a different way of consuming networks with all of the NSX services as well. The external networks also give you the flexibility of consuming any type of gateway. So it could be a router from NSX or an existing device. Then we have routed network profile. So this is where you would need a dynamically created network with unique IP addresses that are accessible end-to-end in your environment. So you can see, actually, this is probably worth explaining. You choose an external network profile that you connect to, and this becomes the uplink of your routed network. You provide a subnet mask. In this case, we're actually providing a /24 subnet. Then you also provide a range subnet mask. Here it's a /29 and a base IP address. And so then VCAC, in this case, we're actually delegating IP address management of this, or allocation of this subnet, to VCAC. So it actually carves up this larger subnet into a number of smaller ranges that can then be deployed and allocated to multiple instances of your multi-machine services. So you can reuse the same blueprint multiple times and still guarantee that you're using unique IP addresses. So then we have our NAT network profile. And really the key use case here is when you have overlapping IP addresses in your application or between your applications, or you might want to deploy multiple instances of that application for, say, test and dev, but you still want external access. So in this case, we actually we still connect to an external network and support two types of NAT. One-to-many NAT, which provides like a port forwarding. So basically, we allocate a single address from the external network and create the source NAT rule so that all virtual machines on that network profile can communicate externally. And then we have a one-to-one NAT, which does essentially a translation. And we allocate, every virtual machine gets a unique address, and we'll program both source NAT and destination NAT rules in this case. And then finally, private networks, which have no external connectivity. So these are really the network profile building blocks that you will use within your applications. And with that, I think we'll now move over into the new features in the 6.1. Actually, before you do that, you have a question? Mm-hmm.
Just repeat the question there, if you could.
Sure. So I think the question there was a question on NAT and how it requires, or it's more demanding on them providing standard packet forwarding. So when it comes to, and this is something that we'll try and highlight in the demo, but when it comes to, if we look at these gateways here, so in the case of the NAT profile, you'll see there that we actually deploy a gateway, so it's actually an NSX edge device specifically to perform the NAT function. So whether you're in routed or in NAT mode, we'll essentially leverage the capabilities of the edge gateway that's optimized to provide those functions for you. So that's actually part of the application blueprint, is all of the required network connectivity. So in this case, you're not leveraging a shared resource, you get a dedicated resource for your application. Okay? Great. Another question in the middle? Right, so I think the question there is whether we have the ability to create selective destination NAT rules. So that's a great question. That's a feature I've been asking for a while. We do either have the one-to-one NAT, but if you're in one-to-many mode, the way to provide inbound access is actually through the load balancer, and that's how we can provide selective access. I still agree, there is a use case to do that with destination NAT, and maybe you'll have to hear an update in our next session on when that's coming. But good question.
All right, thank you. All right, so at the moment, well, one of the moments you're waiting for, what is new in this next release? So here's an overview of what we're looking at, right? A lot of new functionality. I'm going to start down at the lower left-hand corner because I'm partial to that one, is the extensibility. So previously in the version 6 release, those that are familiar with the VCAC NSX integration, is we actually went through and through a model management within VCAC and called out to NSX directly, that NSX manager directly. Now we're actually abstracting that away and doing it through VCO. We'll talk about all these in detail as we keep going. So yeah. From there, be able to, in the connectivity stuff, be able to define routed NAT private networks, just as Ray was just mentioned about. All on demand, which is great. Be able to do security with logical firewalls, isolate the multi-machine service so only traffic is allowed between certain VMs. Whoops, that was not intended there. There we go. And then apply these firewall rules, advanced policies, connect business logic into the security policy. So we're able to actually go in and create security groups dynamically based on the security policies that are being attached to the virtual machines. And we'll see all that in the demo as we go into and do the multi-machine blueprints. And then the availability right now, we're also adding the ability to not only do one-armed as well as inline mode for load balancing, but also connect to pre-existing load balancers. So if you have something out there and you want to add another machine to it, you can do so. Once again, we'll get into all these in turn. So this is a diagram of the previous VCAC 6 capabilities, right? And kind of the model of how we did things. All the business logic lived up there in that VCNS model that I was mentioning before. It lived in VCAC. And then it would go down and talk directly to NSX for vSphere through the REST API, and then NSX would take care of what it needed to by going through and talking to vSphere and ESX directly in the cases that it needed to. Now, we've abstracted that away one step further by putting vCenter Orchestrator in the middle. And vCenter Orchestrator has its own REST API, which VCAC now talks out to, calls specific VCO workflows that are delivered with the NSX plugin. And then from there, VCO actually uses their REST API connector in order to call out to NSX. Now, that comes with a whole bunch of different benefits. And these are all benefits for you, right, is that one, it abstracts it away so that if any other changes happen, like say we come out with a new release that's not in a release of the VCO plugin, not in release of VCAC or NSX, we can get you fixes faster, we can get you new functionality faster, and it doesn't require you to necessarily change anything except for the plugin. All your configurations in VCAC will still remain the same. Easier end-to-end customizations of workflows. So if you need to add some business logic in there into that VCO workflow, you can do so. Also provides self-service access to NSX and VCO workflows through the Advanced Service Designer in VCAC. So those who are familiar with ASD and the Advanced Service Designer know that if you have a VCO workflow, you can call it from VCAC as a day 2 operation on a machine or a multi-machine blueprint. And so that allows you to open up even more use cases to your end users in a self-service capacity, but through a controlled, automated way, right? Something to note, though, is at least for this first release of that NSX plugin, is that it is intended and built to be used with VCAC. So that's not to say that all use cases, all commands, all everything is built into that plugin just yet. Like I mentioned, only the use cases specifically used for VCAC are the ones that are going to release with this plugin. We'll iterate upon that as we go forward.
Actually, one thing I will add there, as you can see in the screenshot over here, this is a full VCO plugin. It's not just consuming NSX through the REST API or through the REST plugin, but it's actually its own NSX plugin. So we maintain a full inventory state in VCO as well. And this will be important, particularly as you're looking at extending these capabilities.
Yeah, thanks for that clarification. Yeah, great. Let's see here, moving forward. So I'm actually going to build this out just a little bit here. So with this next release, we're also able to connect a whole bunch of there's significant enhancements to consumption of distributed logical routing. In the past, on-demand networks would only be used via an edge gateway. But now with this, being able to use the distributed logical router, we can do up to 1,000 logical interfaces all through that distributed router. And then here's some more added benefits of no virtual appliances required for routing, so you're not actually spinning up things into your infrastructure. It's all done through the kernel. Dynamic routing available in OSPF and BGP, and then previously distributed logical routing only could be leveraged on external networks. Now we can do it at the underlying networks as well. Anything to add on that, Ray?
Yeah, probably the only thing I would add there is that this is really an important step in terms of leveraging that functionality in NSX that's embedded into the hypervisor. So now we can actually leverage optimized ingress routing within the hypervisor in a distributed fashion, rather than relying on the edge appliance. So it's about really getting feature parity and consuming as much of the native NSX goodness through vCloud Automation Center as well.
Yeah. Going forward, routed gateways. It's an important concept for routed network profiles. If the routed gateway is a distributed logical router, the routed network profile is directly connected. As you can see here, we've got a screenshot here from VCAC, and this comes from the reservation screen and actually configuring those different routed gateways. The routed gateways is an NSX edge, an appliance-level edge. It will actually be deployed and a stack route injected into the routed gateway for a RAD network profile. So, Ray, anything you want to add in there?
Yeah, so I mean, given this is defined at the reservation level, it really becomes part of your initial configuration. So you can see here that VCAC will discover all of the gateways in your NSX environment, whether they're edges or they're distributed logical routers. Then you'll map a network profile, an external network profile, to those gateways. And then based on how you build your routed profiles inside your blueprint, that will determine which of these two connectivity models that you have. So if your external network links to the distributed logical router, you'll be directly connected and leveraging all of that optimized east-west routing. Whereas if you connect to this external network, you'll have an application level edge deployed. So really, it's an important concept in how you consume the NSX infrastructure.
And so in both scenarios, the purpose is to allow scalability and flexibility, right?
Yes, and to make sure that these applications here that are configured with unique IP addresses are accessible end-to-end in your environment.
Cool. So security groups. So in version 6, security groups were pre-created, right? You would go into NSX, you pre-create them, and then you consume them from VCAC. Workloads were placed onto them, and therefore firewall rules and security groups had to be pre-created as well. So as a result, most apps were being placed in shared security groups, and it limited the application isolation. So now in 6.1, on-demand security groups are based on NSX security policies, which maintain the application context within the security groups. So we're dynamically building those based on the configurations, based on the two, the security group as well, or the security policy and profile as well, right? Together we create the group.
Yeah, so we select a security policy that gets exposed in vCloud Automation Center. And then the security groups will be that are created on demand, and the component VMs that are added into the security group are automatically linked to that security policy. So essentially, we define the policy within NSX and consume in vCloud Automation Center.
Because that's what VCAC is, right? Mainly a consumption tool, allows self-service. Cool. So we'll build this out a bit. So it talks about the members of the virtual machine members and building it in context, and then the services up at the top right-hand corner that you're associating to those. So NSX security tags. They're exposed to cloud admins and VCAC. So basically, can be easily used to define if-then statements. So in the first step, what a person would do to set this up is to set up the security admin preferences at the security group and the security policy. And then from there, we go and the cloud admin actually goes in and builds the machine blueprint, adds the security tag to that multi-machine blueprint within VCAC. From there, end user requests that multi-machine blueprint, right? Goes out to the service catalog and selects it. And then the VM is automatically deployed with its security tag, as you can see in the screenshot right there from vSphere. And then, of course, step 5 is the VM is dynamically assigned to the relevant security groups that were selected that are being built dynamically in the background.
Yeah, so in this case, the security group is actually a pre-created construct, but the membership is based on the presence of that security tag. So it enables you to choose a tag, like in our example here, a PCI protected workload will then get moved into that tag based on security group, based on the presence of that tag, and then we can apply the required services to that security group. It might be some additional, IDS or IPS services or deep packet inspection. So it gives us a very flexible model to consume the security services in the underlying NSX platform.
And we're going to see that later on, right, in the demo?
We will, yes,
yeah,
hopefully.
All right. Next is NSX application isolation. So basically what this does is take firewall rules and make sure that, that nothing, both the incoming and outgoing, doesn't allow any, everything's blocked by default, and allows for component level security applied at higher presence to the permits, to take care of the traffic, basically.
Yeah, think of this as it's a default. You can see here, it's essentially a checkbox that you select on your blueprint, and you're saying that by default, I want to block all outbound and inbound communication and only allow the inter-tier or blueprint traffic. And then based on the selection of other security policies that have a higher precedence, that's how you allow inbound access. So essentially, you're always deploying your application in a secure fashion and only opening up access as needed.
And we use this quite often within VMware to be able to do things like testing pods and things like that in complete environments, so you don't have to constantly be giving new IP addresses. You can use the same ones over and over again, and they're completely isolated from the other machines. Okay, and then here we have the load balancing. So we have two different methods, the one-arm load balancing as well as the inline load balancing. And it depends on what it's connected to that determines if it's going to be a one-arm or inline. And let's see here. If the component VMs are connected to a network using single distributed, or the distributed logical router, then it's going to do the one arm, right, Ray?
That's correct. And also an external network as well. So external or distributed routing, as we can hopefully see.
I think it starts to flash there, yeah.
Yeah. So you can see here, with either of those topologies, given that the default gateway is not capable of providing load balancing, we'll dynamically deploy a load balancer for you connected to the appropriate tier. Whereas if your gateway is an edge, where we can easily enable load balancing, well, in that case, we'll turn on inline load balancing for you. So flexible topologies for load balancing based on how your blueprint is created. Yeah.
All right, moving on there. I'll hand over to you.
Okay, so one thing that if you haven't already, I'm sure you'll hear a lot about micro-segmentation at VMworld. It's a powerful capability of NSX, which is really the combination of isolation, segmentation, and advanced services to provide very granular virtual machine level security and policy enforcement. Now, one point that we want to make is by automating the deployment of VXLAN logical switches, we can provide isolation. Then we can place workloads into dynamic security groups based on the policies and tags that Zach mentioned earlier, dynamically. So that provides us segmentation. And those security policies can also be linked to all of our partner ecosystem of advanced firewalling, guest introspection services for antivirus, intrusion detection, and so forth. And that gives us advanced services. So it's really that combination of leveraging the NSX distributed firewall to provide the controlled communication path and the advanced partner services. This really enables us to provide secure, on-demand micro-segmentation through combining and integrating vCloud Automation Center and NSX. So now I'm going to take a few minutes to talk about deployment topologies. Really, it's because I think the context is important before we jump into the demonstration, and it helps tie together some of the concepts that we've been talking about. So if we start with so what we do is we tend to separate into an on-demand deployment model and a pre-created. And you'll see these link almost one-to-one to those application topologies we talked about. But essentially in the on-demand model, what we do is we deploy a provider logical router. So this is provided by NSX. And it's actually our gateway for routing traffic, north-south traffic to external networks, and then southbound to our logical networks. We also create a transit network, so a VXLAN logical switch, and map that to an external network profile in vCloud Automation Center. We can set up dynamic routing between our provider router and our external networks. And then the last step is we would also pre-configure a distributed logical router and enable dynamic routing there as well. So at that point, we've finished the one-time preparation, and now we can start consuming network services. So in this case, our multi-machine service 1 is actually routed by the distributed logical router. So you can see I have web app and database logical switches, all connected on demand to that distributed logical router. I've asked for load balancing on my web tier, so I get a one-arm load balancer there. And also security through the NSX distributed firewall. And because that distributed logical router can support 1,000 logical interfaces, well, I can just keep scaling horizontally by deploying more applications. Multi-machine service 2 here. In this case, we're routed via an edge rather than the distributed router. So you can see in this case we have to, VCAC will automatically inject a static route into our provided router, but we get the same sort of capabilities, load balancing for our multi-tier applications. So this was really the model in VCAC 6.0. Now with 6.1, when it comes to routed networks, in the most cases you'll be leveraging the benefits of the distributed logical router. Now again, with our on-demand provisioning, we might also need to support overlapping IP addresses. So multi-machine service 3 has a mix of NAT and private networks. Our web network is using address translation, and our app and database networks are private. Which reminds me of an important point. So we can see here in our routed profiles that they're using unique IP addresses. Every logical switch has its own unique IP addresses. And when it comes to our NAT networks, when we deploy another instance, you'll see we're able to use exactly the same IP address space because address translation is performed on our application gateway. And again, this keeps scaling while there are free IP addresses on our transit uplink network. So this on-demand topology meets a number of different connectivity models and scales very nicely. It's really ideal for test and dev type workloads or really more dynamic environments, again, where you have overlapping IPs or you might be provisioning and destroying applications quite quickly. Then next is the pre-created model, and this is one when I work with customers, it really maps nicely to that single flat network model that a lot of customers want to adopt, and it fits production style workloads very well. So on the screen are our pre-created components here. So we're pre-creating not only the provider logical router and distributed router, but we're actually pre-creating the logical switches that our component virtual machines will be deployed onto. So in that case, it's actually this Proto1 and Devo1 logical switch that get mapped to external networks in vCloud Automation Center. First hop routing is provided by the distributed logical router, and then we have our edge gateway in a highly available configuration as a provider router. But now that this is NSX 6.1, in the pre-created model, we can actually support some of the cool new platform features like equal cost multipathing in NSX. So we could actually swap out our active standby edge gateway and actually deploy a scale-out provider router. And in fact, we support actually up to 8-way ECMP in NSX 6.1. So now that north-south bandwidth can be scaled up dramatically. All paths will be active between the distributed router and our edge gateway, and we can also do ECMP with our physical network. So this topology really enables you to leverage a lot of the functionality in NSX. Then when it comes to deploying our applications, our multi-machine service 1 in this case, we'll deploy onto our existing external network. We'll deploy web VMs, app VMs, and database VMs, each in their own security groups. So even though they're on the same network, we've maintained all that application context and can provide isolation and security rules. We also deploy dynamically an NSX Edge load balancer to provide load balancing for our web virtual machines. And when we come along and deploy the next application, well, it connects to the same network in its own security groups with its own load balancer, and we can just keep scaling out and deploying those applications as long as our external network has free IP addresses. Same thing over on the dev logical switch. Multi-machine service 3 and 4. So you can see how this maps very nicely to that flat network model. And really, it's an important nuance that pre-created networks are really important for some use cases, whereas the on-demand dynamic networks are also important for other use cases. They're neither good nor bad. They're just different topologies that may fit your requirements. OK. So with that, we are going to cut over to our demonstration. OK, thank you, Zach. So very quickly, what I will do is give you an overview of our NSX environment just to show you that one-time infrastructure preparation. So I'll click on our shiny Network and Security tab. In the vSphere web client, I'll show you my NSX environment. Actually, sorry, I will log in as a different user. Sorry. We tried to streamline a bit too much there. So now I'll log in as a user who actually has access to NSX. We're really just providing an impromptu demonstration of the role-based access control in NSX. And did I convince anyone there? Okay. So now we can see an NSX manager attached. And what you should see here is our NSX control cluster of 3 nodes. So this provides our centralized network state information. We've also prepared our hosts for NSX. So we pushed down all the required kernel modules for VXLAN, distributed routing, and distributed firewalling. And one other thing I'll show you is that we actually have, in this case, a routed VXLAN transport. So our VTEPs or VXLAN tunnel endpoints are on different networks. And when we provide a logical switch, we're giving you layer 2 networks on top of a layer 3 physical network. This is that decoupling from the infrastructure that we talk about with NSX. So I have on this network one logical switch, a transit network that gets mapped to an external network in vCloud Automation Center. I should have 2 edges. So one is my provider edge. So in this case, if we have a quick look, what you'll see is that the provider edge actually provides the default gateway on that cell's transit network and an uplink to the rest of my physical network. I've also enabled BGP on the provider router so that it could exchange dynamic routing protocol information with the distributed logical router, which we'll quickly zoom into and show you that on the distributed router, we actually only have a single interface, which is the uplink. So this is all we need to pre-configure on the distributed router. And again, we can optionally enable dynamic routing, which we have done. And then I'll quickly show you the security groups, and that's really it for the NSX preparation. So in this case, what we have are one security group here for finance that has dynamic membership based on the presence of a security tag. So you can see here, if we have this PCI protected tag, that's how we determine membership of that security group. And we also have security profiles here. So we have one security profile that was created by VCAC. This is actually our application isolation policy. And you can see that it is allowing the intra-tier traffic and then blocking all inbound and outbound access, as we talked about. And then I've defined additional security policies. So one at a default level, where I actually want all my, I want to permit DNS traffic for my applications, all virtual machines. And then more granular policies for web app and database virtual machines. So in the case of web, for example, I'm permitting inbound traffic for HTTP, HTTPS, and SSH. I'm then permitting certain traffic to the application tier. And then I've decided there's no reason for my web virtual machines to communicate with each other, so I'm blocking that traffic as well. And then, similar rules for application and database, as you can see. Next thing we'll do is cut over to vCloud Automation Center and just quickly show you from the cloud administrator view, how do we map to NSX and consume this networking security services.
And as Ray goes through this, you'll note that there's only really 4 main steps that we're going through. This is step 1, the configuring your endpoints.
So you'll see here that under our vCenter server endpoint, we also specify our NSX manager. And
this is the same as 6.0, right?
Absolutely.
Yep.
But new is, it's now mandatory to have a VCO endpoint as well. And this will be the VCO endpoint where our NSX plugin is installed. And it's actually the VCO plugin that runs all of the workflows and business logic when it comes to provisioning on NSX. So then once we have set up our endpoints, data collection will be performed both on vCenter and on NSX Manager. And then we can create reservations.
So this is step 2, the network profiles aspect of it?
Yeah, so what you'll see here is, I have a number of network profiles here where I'm actually mapping. In this case, I'm actually mapping that transit uplink that I showed you in the NSX environment with a default gateway here of 192.168.10.1. So it matches that internal interface of the provider router. I also have the various NAT and routed and private profiles. So actually, in the interest of time, I'll keep this quick. But you can see here that we're connecting to a specified external network, providing a subnet mask, a range subnet mask and base IP, and then all these ranges full of unique IP addresses are automatically generated by VCAC to be deployed or to be allocated to our multi-machine services. So once the network profiles are set up, so this is typically done in combination with your network administrator, then we set up our reservations.
Which happens to be step 3.
So if we look at our reservation setting, I'm going to skip to networking tab because that's where anything interesting happens in IT. I was waiting for a response from Zach there.
I already zoned out.
And actually, you can see here under our advanced settings, based on our data collection from our endpoint, we can choose a transport zone. This is where all of our logical switches will get created. A default security group is selected, so it means any virtual machines in this reservation will get placed into the default security group. And we've also mapped our routed gateways so we could consume distributed logical routing in our blueprint. So once we've set up our reservation, we will then show you the blueprints quickly before we kick off provisioning. So what I'm going to do is actually show you an instance of our production application that uses routed networking. And you'll see here that, again, skipping to networking, of course, I have 3 tiers, a web app and database tier that are all routed and that are actually connected to an external network profile of 2. And this happens to map to our distributed logical router that was defined back in the reservation. So these are routed networks that would get that optimized routing. And I have different networks for web app and DB, all in different subnets. Then I add my component, I also enabled application isolation because I'm very security conscious. Then in my build information, this is where I add the component virtual machines. And if I show you my web tier, you'll see it's connected to the routed profile for web virtual machines. I've enabled load balancing, so HTTPS load balancing on that routed network profile. And then on the security tab, I'm choosing the security policy that I want to take precedence over my application isolation rules, and also a security tag down here for PCI protected.
Screen flash just for 1 second.
Sure. Okay, now I'll just show you application tier to highlight, well, or not show you. Here we go. Now our application virtual machines are connected to the application tier, and they're actually leveraging different security policies and also different security tags. And the database tier looks very similar. Then we actually publish this multi-machine blueprint. And what I'll do now is actually log in as a regular user to the vCloud Automation Center portal and kick off a request of this multi-machine blueprint. So if we look at the catalog, these are all the multi-machine blueprints that are exposed. I'm going to ask for an instance of my Vulkan prod application. So what we'll see here are the various components, our application, database, and web tiers. Because I have load balancing enabled, and load balancing is no fun with only 1 machine, I'm going to go and bump that up to 2 machines, hit submit, and cross my fingers.
Which you could also take care of later on, right? Adding components in through VCAC.
You can, actually. Yep. Great point, Zach. So yeah, even if you were allowed to deploy more component virtual machines, you could increase those after the request as well. So I got the green tick, so life is good. Now, as the application, this could obviously go through a standard approval process in vCloud Automation Center, but I'm interested in instant gratification, so we don't do that. And now we can see our application has a status of in progress. So user Bob is going to wait, with a couple of clicks, he's done everything he needed to request his application. Now VCAC will be busy provisioning that application based on the blueprint. And really what we'll see is that vCloud Automation Center is going to follow the pretty logical process of creating the required security groups, then the required logical switches, routing, edges if we enable load balancing, then deploy the component virtual machines, add them into those required security groups that are really needed to deliver every step of this workflow and give you a functioning application at the end of the day. So what we'll do is quickly look. Now we'll switch back to the administrator view and make sure that VCAC is actually executing a workflow, which is good.
Always a great sign, yeah.
In fact, if we look at the audit log, we can actually start to see a number of security groups are being created based on our request. So we can see that security group is created. So let's actually go back to the vSphere web client, refresh our security groups, and you'll see here that we have additional app isolation security groups that are created based on our web app and database tiers for our application. So here we go. We can see the various security groups are being created. Then the next step after creating the security groups will be creating any of the required networks. And in fact, now you can actually see I have switched back to the C# client only because it provides this lovely recent task view. But you can see a number of port groups are being dynamically created by vCloud Automation Center. This is all happening in an automated fashion. So if I go back to the vSphere web clients and look at logical switches, because I asked for on-demand networks, what we'll see is actually web app and database logical switches created by VCAC to support our required application.
So to tie that back, Ray, you've supplied self-service to your end user to get their resources as fast as possible while giving the admins the control they're looking for.
Yeah, absolutely. So this blueprint was defined by the cloud administrator with all of the security policy and network profile policy that they required. And this is all being handled automatically for the end user. So at this point, what we can also see, after those logical switches have been created, VCAC, because we asked for load balancing, is also busy provisioning an NSX edge device to provide load balancing. So if we go back to the vSphere web clients and look at NSX edges, we should see a brand new NSX 6.1 edge has been deployed by vCloud Automation Center. And it should be actually connected to our web logical switch because that's where we asked for load balancing to be performed. And in fact, it is. You can see here a single interface of this edge is connected to the web logical switch. Okay, all right. Okay, we'll try. Okay, you can also see that we're building a firewall rule set here on demand based on the required services that are configured in our application. But at this point, load balancing has not been enabled yet. If I go back to my distributed logical router, what I should also see is dynamically created internal interfaces. So these are the logical interfaces created to handle a routing between my web app and database application. So you can really see we're following that logical process in a fully automated fashion. And now what I should see, if I go back to my edge device, I should see load balancing. So VCAC is now in the process of assigning the required addresses and enabling the load balancing service on our edge as well. So actually, while this is occurring, you can see load balancing now has a status of enabled. I have a virtual IP allocated for load balancing, and actually a pool that contains the two virtual machines that I asked for in my web tier. You can see they're actually members of this load balancer pool. So I have two members down here. If I click on Show Pool Statistics, what you'll actually see is the pool status is down. In that case, this is entirely expected because VCAC should now be in the process of actually cloning and provisioning the required virtual machines for my multi-tier application. So you can see now it's actually provisioning the required web app and database virtual machines. So while it is doing this, it's a good opportunity to cut over to vCenter Orchestrator and actually show you, under the covers, what workflows are actually being executed to enable this one-click magic provisioning. So you can see here that we have created security groups through vCenter Orchestrator. We have created logical switches. So these are using all of the workflows that ship in the NSX VCO plugin, edges, and so forth. So you can see how vCloud Automation Center is consuming VCO to perform the underlying provisioning.
And again, if you have any need to use these workflows against on a one-off type basis, not in correlation to using or provisioning a virtual machine during the lifecycle of that machine, you could call out using VCAC's Advanced Service Designer directly to those VCO workflows.
Okay, so what we're going to do, I'm going to quickly show you how these virtual machines, in this case, they're prefixed with our application name, are actually connected to the logical switch. So in this case, Vulkan 02 is connected to the database logical switch. Vulkan 03 should be connected to the application logical switch. And our other two virtual machines are connected to the web logical switch. What we might do now, because I think we're a little short on time, is I'm going to let VCAC finish the provisioning, and then we'll come back and refresh the load balancer and show you how the security groups and tags are populated. But in the interim, I think we might take any questions.
Sure.
Yes, up the back.
Are all these VCO workflows pre-built?
Yes, they are. They are. So when you install the plugin, you get all of those workflows that I showed you, yes. So you could run them independently as well.
And I want to add, they're not even drag and drop. Because they're out of the box, VCAC automatically knows how to use those VCO workflows. You don't have to configure anything past that. It already calls them by name.
Are we going for time?
3 minutes.
Okay.
Real fast, while we have some of your
fine.
attention, also don't forget about the hands-on labs, which we show VCAC with NSX, as well as the NSX labs as well, if you're interested in finding out more. There's a question up here in the front.
Yeah, I don't know the program for it, but the distributed logical router, the protocol here goes via BGP, traffic flow back to the peer. How does that function? Is it a single peer for the entire distributed logical router? And if so, how do you get the traffic back to the other distributed points without doing that?
That is a question I think would be great to handle afterwards, because it's kind of detailed and it's not specifically related to the NSX VCAC integration. So I'm more than happy to cover it, but we'll do it after the session.
Anybody else? Yeah, in front.
Required version of vSphere for NSX 6.5.
5.5. There is a subset of functionality like the distributed firewall that will work with 5.1, but you still need vCenter 5.5. So actually, now you'll see that VCAC has finished provisioning. Well, you won't see it. You'll see that VCAC has finished provisioning the virtual machines and has customized them with the appropriate IP addresses. So now if I actually go back and look at my load balancer pool, and again cross my fingers,
Drum roll.
you'll see the load balancer pool is now showing a status of up. So load balancing is working. And if I look at my security groups, you'll see that a number of these security groups have been dynamically populated and are actually contain the virtual machines of my application. So I have all virtual machines in the default security group selected at the reservation level. And for example, this will be my web security group, which only contains the web virtual machines. Okay, so now what I'll do is also, let's refresh our user provisioning. And you'll see that the application is successful. So I'm going to show you the very last bit, just to prove that the demo actually worked. I know you're all in suspense. So now this is really the end user again. They're now looking at their provision multi-machine service. And what we do is, because we've enabled load balancing, we also allow the end user to retrieve the virtual IP that was assigned. So in this case, you can see we've assigned on the routed web profile an IP address of 172.16.10.10 for load balancing. So user Bob is going to open a browser and actually try and access that. And you can see here. So now if he refreshes, he's now being directed, load balanced between two different web servers that connect to an application server and are retrieving information from the database in real time. So we've showed you this one-click provisioning of a complex multi-tier application. So with that, for those of you who stuck to the end, thank you very much.
Thank you.
And we'll be around for questions. Thank you.